Hello guys, welcome back to CS with Mr. G. This is the first video in a series of 3 videos which we will review Unit 3. As Unit 3 is quite a large unit, I have split it up in between the CPU and storage, which we'll do today. Then we'll look at input, output and sensor devices in a different video. And in the third review will be network hardware, which will come at the end. But in today's lesson, we are just looking at the CPU and storage, where we will go over some past paper questions, looking at the requirements for these questions and some typical mark scheme answers which you can expect in your exam. So first things first is a question on registers, so the registers within the CPU, and on the left we have a list of registers with some statements on the right. All we have to do is link them up, matching up the definitions with the correct register. So what I would do in this type of question is I would look at the registers at which I know, and I could probably define without looking at the definitions on the right, and I know that the accumulator is where the answer is stored after an arithmetic or logical expression. So in the definitions we can see used for temporarily storing arithmetic and logic results. The program counter, the PC, points to the next instruction that needs to be executed, and then the MDR and MAR, well, the clues in the name. The memory address register clearly stores the address of the location in RAM, so that's that one. And the MDR, which is the data register, stores the actual instruction or the data, with data being the keyword from the D in MDR. And then finally, the current instruction register is the current instruction being decoded and executed, which is clearly the one at the bottom. Next, carrying on with the CPU, tick one box in each row to show whether the statement is true or false regarding the statements around the CPU. So the first statement, CPU stands for Central Programming Unit. We know that that's false because it's clearly the Central Processing Unit, so that will be labelled as false. The CPU carries out arithmetic and logical instructions. That is true. And registers are a type of superfast memory in the CPU. That is also true. The von Neumann architecture only holds data in memory. We know as false, because the von Neumann architecture implies that we have stored memory in the form of RAM and the registers within the CPU. So that last one's quite tricky, but go and look up the von Neumann architecture if you are struggling, which can be found in Unit 3, Lesson 1. Next, the CPU operates on a cycle. What is the name of this cycle? FDE, but please be careful and try and label this as the full name, which is the fetch, decode, execute. Always think back to the company FedEx. The FedEx logo, as you can see, we can split it up with fetch, decode and execute. Next up is a question about the cache within the CPU, and we need to describe how cache is used, and we need to describe how cache will affect the performance of the CPU in a general computer system. So first and foremost, cache is a faster version than RAM. So cache transfers data faster than RAM. That will be 1 mark. The processor will look to the cache first before it looks to RAM. CPU looks in the cache before RAM if it finds it. So if it finds the data, there is no need to look in the RAM. If not, it will look in the RAM, which, as we've just said, the access speeds in RAM is slower than it is in the cache. Therefore, if we increase the amount of cache, so increase the amount of cache means more data will be found quickly, as it will save time having to go to the RAM each time it's looking for data. So as this is a 4-mark question, I'll go over some extra points that you could put. You could also mention that cache has various levels. So cache has several levels, and that the faster levels are tried first. So that's level 1 cache, then level 2, then level 3. Question 6 is the term bus, and that the CPU features a number of different buses that make up the system bus. We have to describe the term bus in general, and for 1 mark, a bus is simply a collection of wires which transfer either data or control signals. You could mention that they transfer from one component to another. So just to be safe, if it was a 2-mark question, you would mention that it will be from one component to another. The 3 buses you'd want to mention as well are the control bus, the data bus, and the address bus. And they are the 3 buses that are involved within the computer, which in question 7, we have to state the role of each bus, which is fairly straightforward, where the clues are pretty much in the names of each bus. So firstly, the address bus transfers memory addresses, which are to be read or written to. So whether we're putting data inside of it or getting data from RAM, we need to know whereabouts it's going with the address, and that's transferred on the address bus. The control bus carries control signals, which coordinate, which means keep a track and make sure everything's running smoothly, all of the CPU activities. So this fetch, decode, execute cycle needs to be managed and maintained, and this is done so by the control bus. The data bus clearly transfers data between CPU and RAM, and also input-output devices. So again, clues are in the name, guys. You've got the address, control, and data. It's fairly simple to correlate those answers to each bus, and they are the only 3 buses that we need to know. A dual-core computer has 2 cores. Explain the 2 components that each core will contain. So hopefully you can remember what is inside each core, which allows the CPU to essentially double its performance. And one core contains a set of registers, so its own registers to store tiny amounts of data. It has a control unit, an ALU, which is the arithmetic logic unit, and finally it has its own cache. Now, as this question says explain 2, what you would need to do is pick 2 of those and then explain what that part does. So if we talk about the registers, we would say registers are used to store small amounts of data. For example, instructions. If you're talking about the control unit, this controls the timing of the CPU and links heavily with the control bus from earlier. So the control unit and the control bus work together. The ALU, which a lot of my students tend to find easy to remember, performs calculations, keyword being arithmetic. You should know what arithmetic means, so that the ALU performs arithmetic, and just to be safe, it also performs logical expressions as well. So logical expressions are also performed by the ALU. And finally, the cache we've just spoke about, and this is dedicated memory similar to RAM, which is assigned to each core. So all you'd have to do, guys, for the 4 marks would be to name 2 and then explain what each of those do. Next up, we have an embedded system, which was a fairly simple analogy to understand, and it was basically a CPU that lives within a device that performs a specific task. So for example, a microwave or a washing machine has an embedded system as it contains a CPU and RAM all in one place. So our definition, so that it's a computer system that performs a specific task. That will be 1 mark, so a specific task. You would mention that it contains ROM and RAM in order to function or in order to work. And then you can also mention that it's part of a bigger system, so part of a bigger system, and then give an example. So e.g. a car, washing machine, or any other embedded system that you can think of. Question 10, the differences between RAM and ROM. Nice and easy. RAM, random access memory. ROM is read-only memory. RAM stores the OS when it's running programs, and any data in use. So my device now has this PDF file open, as well as the background tasks running by the OS. The ROM stores the BIOS, or you could say the boot up instructions, or the instructions to simply start up. What happens when the power is turned off? Well, RAM loses data as it is volatile, and ROM keeps data as it is non-volatile. And the easiest way that I remember that is the O in non, and there's an O in ROM, or non also sounds like ROM. So that's the way I remember. But basically, ROM doesn't lose the data, so take the word no from non. No, it's not going to lose the data, whereas RAM will, as it's volatile. Can you read from and write data to it? RAM, of course you can, and ROM is obviously not, because it's read only, so this will be a no. So 4 marks, guys, 1 for each row. But RAM and ROM, again, being covered heavily in this unit, as it comes up quite frequently in the exams, so please make sure you are on top of it. Explain why increasing the amount of RAM will improve the performance of a PC. Well, as we know, the RAM stores running programs, so having more RAM would equal more running programs, which means better multitasking. And if you want to be technical and quite specific, you could say data stored in RAM is accessed much quicker than secondary storage, which means the CPU can access more data a lot quicker. What happens when a RAM becomes full? Well, it uses virtual memory. Describe how virtual memory works. Well, virtual memory, if you remember, is stored on the secondary storage. So virtual memory, I'm just going to shorthand VM, is a temporary storage. So is it a temp storage on the hard drive, the HDD. When RAM becomes full, the computer will store running data in virtual memory, which will free up space in RAM, which allows us to store more in RAM and prevent the computer from crashing or running slow. Now, obviously, the HDD and SSD aren't as fast as RAM, hence why increasing RAM is a better solution than assigning more virtual memory. Question 13, complete the table below. We have to determine which one is being stored in RAM and which one is being stored in ROM. So an MP3 currently playing in the web browser. So if you're streaming Spotify in your browser, that means it's a running program, it's data currently in use, and we know that is in RAM. A Word document currently minimized, it's still open, it's still in use, it's in the RAM. The BIOS, as we've just discussed, is in the ROM. An email currently being written, again, it's being processed, it's open. Instructions on how to start up, the ROM, and the game currently being played, RAM. So that one's fairly simple and should be a guaranteed 6 marks. Define the term main memory. Now the key to this is what's the difference between primary memory and secondary memory. So primary memory, or main memory, which is RAM, is directly accessed by the CPU. And this is a key definition which I've seen many times directly accessed by the CPU. For the second mark, you could say that it's volatile or short-term or even temporary method of storage. Secondary storage is the opposite. It's non-volatile, it's long-term or permanent, but it's only one mark for one of these, just like it's one mark for the three above here. So just be careful, only use one of those terms. You won't get 3 marks for naming all 3. And clearly the difference is this one, so it's not directly accessed by the CPU. Question 15, let's look at the storage devices and label which one is magnetic, optical or solid state. So HDD, you should know, is magnetic, a Blu-ray is optical, CD-ROM also optical, USB flash drive, solid state, a DVD RAM, optical, SSD, solid state clearly, SD card also solid state, floppy disk is magnetic, and backup tape is also magnetic. So that should be another guaranteed 6 mark, guys. If you struggle with those 3 types of storage, please go back and watch the video on that. I have some clear and easy to understand demonstrations, so please be on top of secondary storage. And here we have 2 features of magnetic storage, and we need to refer to the platters, which are the magnetic disks inside the HDD, and platters are split into tracks and sectors. Again, if you're unfamiliar with this, please go back and watch the video. The disk is spun and there is a moving arm which reads the data. So quite a complex process that goes on with magnetic storage. Solid state is a bit easy to remember. Solid state uses transistors and uses what we call NAND technology. So NAND technology, just think back to the Boolean logic lessons in Unit 10. If you've not done them, you will come across them soon, but it uses NAND technology. Again, another tricky question that can pop up, but please be aware of solid state. It uses transistors and NAND technology. Next up are some descriptions. We need to label what type of secondary storage is being described, and the term pits and lands refers to optical storage, control gates and floating gates. Well, I just mentioned Boolean logic. You should remember logic gates, and that is solid state. Electromagnets, clearly magnetic. Data is stored using a laser, is optical. And then the tracks and sectors we've just mentioned is also magnetic. Here we have a question which ties in with network hardware, but does come under the term for cloud storage as well. So let's start with a server, and you should know that server is an item of hardware which responds to requests by processing data and sending replies. A data center is a centralized collection of servers stored in one building, and cloud storage means storing data on the internet, which leaves scalability and redundancy. Scalability is the ability to increase and decrease, and redundancy means that having data backed up reduces the chance of having redundant data and essentially refers to a backup. And finally, some questions on cloud storage. 2 advantages. You could talk about accessing data anywhere in the world. You could also consider it as a safe backup method, and you could also say you only pay for what you use. However, cloud storage does come with a huge disadvantage, and that is cloud storage is totally reliant on an internet connection. So reliant on a stable internet connection, as without the internet you simply cannot access your data if it's being stored in the cloud. And that's it, guys, for our past paper questions on CPU and storage. The question paper and mark scheme is available in the description below. There are 2 more review lessons for Unit 3 which I've mentioned, and please follow along to make sure we are on top of this unit, which is, as I've said, quite a large unit where you should be able to collect a large amount of marks in your exam. But as always, guys, thank you very much for watching.